The objective of this screencast is learners will be able to determine the zeros, asymptotes, and point discontinuities in a rational function. Okay, this function here on the left side of the screen is a rational function. It's a function whose function rule is a rational expression. Now I created this graph you're looking at with Desmos, and I embellished the graph a little bit. If you type this function into Desmos, you wouldn't see the horizontal and vertical asymptotes, but I put them on there anyway. I chose to highlight a couple of key points here, and you wouldn't see this point at all either. So we're going to talk about what's here. What I see is a horizontal asymptote, just like the reciprocal function had, a line that supports the shape of the graph as the x's get closer and closer to this vertical asymptote value of -3. Here the y's from the right side are getting huge in the negative direction, and from the left side, as the x's approach x equals -3, the y's are getting infinitely huge in the positive direction. And what I hope you'll see is maybe a possible connection between that vertical asymptote and this factor of the function. What I also see is a horizontal asymptote that supports the shape of the graph in a different way. We'll show you the rule for that one in a second here. I hope you see a connection between maybe this point, which is the x-intercept, and this factor here. And what I really hope you see is this missing point in the graph here. Can we talk about why that's not there for a minute? If I were to choose to let x be -1 in this function graph, the rule says that if I let x be -1, like if I put -1 in for x, this whole factor would be 0. And in fact, this one would be 2. So the reason why there's a hole there in the graph is that there can't be a function value when x is -1 because it gives you 0 in the denominator. So let's formalize this by looking at some of the more specific rules we need. Okay, there is a lot of information on this slide, and this is a place where you may want to refer back to or maybe pause and jot some of this down. But for a rational function, a horizontal asymptote, it says if the degree of the denominator is greater than the degree of the numerator, or in other words, if the biggest power in the expression is in the denominator, then y equals 0 will always be your horizontal asymptote. And the reason why that is that if the biggest power of x is in the denominator, as x's get huge, the value of the output value will approach 0 simply, because that big power of the big X value will make the fraction value of the entire expression get closer and closer to 0. If the degrees are equal, however, then we're going to use the leading coefficients to determine the horizontal asymptote. In that case, if the powers of x are the same in the numerator and denominator, then essentially those ratios will equalize out. For the vertical asymptote, you're looking for factors of only the denominator that give you an equation of the vertical asymptote. For the x and y intercepts, the x-intercept comes from any factor that is only in the numerator. We'll give you the x-coordinate of an x-intercept. Of course, the y-coordinate of an x-intercept is 0. To find the y-intercept, I'll simply let x be 0 and find f of 0, and plot the point 0, whatever f of 0 is. And the holes, these are what we call point discontinuities in the target, but very informally, mathematically, we call them holes in the graph. If any factor is a factor of both the numerator and the denominator, the x value associated with that will tell you where there would be a hole in the graph. And to figure out exactly where that point is, you'd want to plug that value into the leftover part of the function to get the y-coordinate. There's a lot of information here, and we should just get to work practicing finding this information. Okay, so here is a rational function. I'll point out that this one is already factored for us. That's kind of nice to have. We want to determine all of this information if we can. So what I actually would like to see first is if I see any factors that are common to both the numerator and denominator, and here I see an x minus 3. So what I don't want to do is divide them out. I could simplify it like we did in a previous learning target. What that tells me is that there's going to be a hole in the graph at x equals 3. And the reason I know 3 is the x value is because that's the value for x, that if I made x3, I would get 0 for both factors. To find the y value, what I want to do is I want to think about the leftover part. X plus 2 on top and x minus 1 on bottom. Or in other words, simply the factors that don't go with the whole. And if I let x be 3 in the leftover part, like this, all I'm doing here is replacing 3 with x here and simplifying. So that's 5 on top and 2 on bottom. That's the y-coordinate. The hole in this graph would occur at 3, 5/2. Now, for the factors that didn't pair up, the numerators factor tell me where the x-intercepts are. X is negative 2. Negative 2 is the x value that makes that factor 0. So the x-intercept is at negative 2, 0. The denominator, this factor here, x minus 1, if I set that equal to 0, gives me a vertical asymptote of x equals 1. I would sketch the vertical dotted support line at x equals 1 here. The horizontal asymptote, let me think about what the degree of these would be. If I multiplied the numerator out, like with FOIL or the box, I would get x squared plus, and it really doesn't matter what else. If I did the same thing on bottom, I would get x squared plus something. So since the degrees are the same, I want to look at the coefficients. 1 over 1 is 1. Gives me y equals 1. The y-intercept, all I'm going to do is I'm going to let x be 0. So if I let x be 0, and I want to look here maybe at the version of this without the holes in it. If I let x be 0, I would get 0 plus 2 over 0 minus 1, and that gives me negative 2. So the the y-intercept is 0, negative 2. Okay, here's another example, and what I hope you see here is that a difference here is that this thing is not already factored. So there's only one factor of the numerator, x minus 4 wouldn't factor, but x squared minus 3x minus 4 would, if I factored that expression as x, let's see, I think I need minus 4 and positive 1. Does that multiply back out to x squared minus 3x minus 4? Yes, it does. So let's see if that helps us analyze this function here. I'll think about the holes first. I do see a factor in both the numerator and the denominator. So x minus 4, if I let x minus 4 be 0, I would get x equals 4. If I thought about what this expression would look like if I divided out the x minus 4s, I would get 1 on top, and I would get x plus 1 on bottom. And if I plugged 4 in for x, that would make the output value 1/5. So my hole is at 4, 1/5. Now, the x plus 1 that's left in the denominator tells me that x equals negative 1 is a vertical asymptote. There are no factors of the numerator left when I thought about dividing out the x minus 4. So what that tells me is that there are no x-intercepts. this thing will not cross the x-axis. To find the horizontal asymptote, I want to look back at the degrees, and I see that the degree of the denominator is greater than the degree of the numerator, and that tells me that the horizontal asymptote will be y equals 0. And for the x-intercepts, what I want to think of, for the y-intercept rather, I want to think about going back into the simplified expression and replacing x with 0. After all, that's what you do to find a y-intercept. And I simply get 1 over 1. So the y-intercept is the point 0, 1. Okay, this one's for you. Hit pause, see if you can sort it out. And when you think you've got it taken care of, hit play to get some feedback. Both the numerator and denominator here need factored. If I factor x squared plus 3x plus 2, I think I need x plus 2 times x plus 1. If I factor x squared minus 3x minus 10, I believe I need x minus 5 times x plus 2. And what I see is that I have a factor of x plus 2 in both the numerator and denominator. So that tells me the x for a whole would be at negative 2. If I think about the expression that's left over, it would say x plus 1 over x minus 5. And if I thought about putting negative 2 in place for x, I would get negative 1 over negative 7. I would get 1/7. A hole in this graph would happen at negative 2, 1/7. There's a factor of the numerator left over, x plus 1. If I let that be 0, that tells me I've got a x-intercept of negative 1. And the y value ought to be 0. So how about negative 1, 0? The leftover factor in the denominator, x minus 5, tells me that x equals 5 would be the vertical asymptote. The degrees of the numerator and denominator are the same. So here's again where I want to think about that ratio of leading coefficients. 1 over 1 gives me y equals 1. And then the y-intercept, if I take the same expression, the leftover expression, and replace the x's with 0, I get negative 1/5. So how about an ordered pair something like 0, negative 1/5? Thanks for watching.